Hi, this is Peaceful Science. I'm here with Ken Miller and Nathan Lentz to talk about the Dover trial, which happened 15 years ago. Ken Miller is here in this court illustration right there, which he has everywhere. That just kind of enshrines it in history because they weren't allowing photographs at the time. And he was one of the star witnesses really defending his textbook from some real objections that ID had to how it was teaching evolution. And we had Eugenie Scott from the National Center of Science Education here. Then we had Michael Behe last week. And then now we have Ken Miller here, and we're really glad to have you here. The title of this is actually, a textbook biologist at the Dover trial. Why would I call you a textbook biologist? What does that mean, Ken?
Well, it's a term I resent because I'm a lot more than a textbook biologist. I'm also a researcher. And of course, I'm an educator.
But also, in addition to actually writing the most widely used biology textbook in high schools, right?
Yeah. So the textbook part, that's an important part of my professional life. I won't make any bones about that. But what it amounts to is a little more than 30 years ago, a former student of mine called me up and convinced me to do something absolutely crazy, absolutely nuts for somebody at a research university. And that is to write a textbook. And moreover than that, to write a high school textbook. And his name was Joe Levine. I told him over and over again he was nuts. I didn't want to do this. At the time he approached me, I was about 18 months away from a tenure decision. And, I tried to explain to him that if word got out I was writing a textbook, that would be zero in terms of credit on a promotion to research university. And if word got out that I was writing a school textbook, it might be less than zero. So when I came up for my first tenure promotion, which I did receive, I actually concealed the fact I was writing a textbook from the promotions committee. And it just emphasized my NIH and NSF grant renewal. So I think that was a good move. Very much to my astonishment.
And you're a biologist at Brown University in Rhode Island, right?
That's correct. Brown University in Providence, Rhode Island. Very much to my astonishment, our textbook really stood out, the very first one in the crowd, because it was really the only book out there at the time that was actually written by two active researchers. And I think it showed. Teachers picked up on it right away. They said there was nothing quite like it, and it immediately became sort of a bestseller.
I actually had that textbook, the elephant textbook. Did you have the elephant textbook too, Nathan? You're not.
No, I didn't. I can't remember which one I had. But I know it wasn't that one.
I was going
to say.
If you did use it, Nathan, you would have remembered. Okay, and let me explain. Exactly. Let me explain why. And Joshua, you asked me to see if I had the textbook right here, and of course I do.
I looked for mine. I couldn't find it. But that was my sophomore biology class. When I picked that up, man, I was a creationist.
There you go. Well, I'm glad it had an influence on you. But anyway, here's the deal. When that book came out, which is in 1990, for the very first time, I saw myself marketed, which is, again, for a researcher and academic is really strange. And what happened is, our marketing people had picked that gorgeous painting of the elephant for the cover of the book. So the very first place where the book was actually marketed was in the state of Texas, which was doing at the time a statewide science textbook adoption.
And this is like in 1990?
This was in 1990 and 91.
Okay.
So as it turns out, we were up against about 7 competitors from different publishing companies. So the marketing people or the salesmen for the other companies immediately came up and said, "Oh, it's the elephant book because it's so big and thick and heavy. That's why it's the elephant book." So they sort of made fun of it. But the marketing director for Texas, clever guy, turned it right around. And what he did was to tell teachers, but an elephant never forgets.
And
therefore, so you wouldn't think that a science textbook would be marketed.
So what you're telling me, though, is news to me. You're saying that it was a real break from how textbooks were written before. It was different.
Yes, in many respects. First of all, it was a lot more up to date. The second thing, and this is one of the reasons that I was convinced by Joe Levine to go in on textbook writing. I had 2 young kids at the time. is I looked at the other textbooks that were available, and of course they all kind of covered the field of biology. But when I read them, I thought they had two flaws. The first one was every single one of them was just as boring as all get out. And I couldn't imagine that any young person would read any of these books and say, yes, I want to be a biologist. So that kind of irritated me. The second complaint I had was they all were written in a way that kind of gave the impression that everything in biology was already pretty well figured out. So all you had to do was to memorize what was between covers and you knew biology. And of course, I'm a researcher, and I know darn well we don't have everything figured out. And quite frankly, that's part of the excitement and the allure of science.
Absolutely. The bad news is, though, that's still how it was taught when I went through it. So
sure.
Even with your book, it seemed like biology is all about memorization, which was
but I'll give you an example that was right in that book. I wrote a feature in one of the chapters on microbial biology called "Is There a New Kingdom?" And at the time, there were basically the three kingdoms. There were the prokaryotes, the animals, and the plants. And a number of scientists, and this is about 30 years ago, had begun to investigate a group of microbes that at the time were just called methanogens because they produced methane. And they'd done a little bit of DNA sequencing on them and discovered that these bacteria were more different from other bacteria than other bacteria were from us in essential molecular details. So I picked up on that and I said, the time may come in the future when we take these oddball little critters and discover they deserve status as a living kingdom of their own. Well, it turns out those are the archaea or archaebacteria, and they are regarded now as a major domain of life that hitherto had been unexpected. So wherever I could in that book, I tried to drop in a little anecdote about, this is new. We don't quite understand this. And that's been the hallmarks of our books ever since.
Well, now I want to go back and pick that up now that I'm actually a biologist to see, how my kids are going to be taught and, think about that. Because, it wasn't until really, honestly, I was in a research group in college that I really experienced, I think, science as a scientist rather than as a student, where you're kind of facing the unknown, not sure what you're going to find out. And that was exhilarating. It was exciting. And it's almost nothing like what science education is.
Sure.
I mean, is there a way around that, or is that just kind of what we stuck with?
I think there is a way around it. And the way around it is to concentrate on hands-on science, to let kids do their own investigations, rather than say, okay, here's an experiment. You mix this, you mix that, you heat it, you pour it into this, and you ought to get the following. Aha. That's called cooking. It's the Julia Child approach to biology. Not that there's anything wrong with Julia Child, but that's not science. That's cookbook. And I think you have to allow for all sorts of open-ended things. And I'll just give you a quick example. I had a marvelous biology teacher in high school in 9th grade. And in the pathway that I walked to go to the public high school I went to in New Jersey, there were some woods and there was a little pond and so forth. And one day, after we had learned how to use the microscopes in the biology classroom, he said, why don't you guys take some test tubes, and on your way to school, maybe tomorrow or the next day, pick up some of that green scummy water in a place called Milton Lake and bring it to class, and we'll see what we can find. And I did that, and I put those things out on a microscope slide, and it just blew my mind. The sort of little critters that were in there swimming around, gobbling, green ones, red ones. It was just amazing. And of course, you can open a textbook and you can see images, microscopic images of organisms. But man, there's nothing like picking something up in your own environment, looking at it, and having your mind blown. And from that moment on, I'm really serious about this. From that moment on, I was a biologist.
Well, I mean, you must have had, so in a lot of ways, honestly, it seems like this is not what you set out to do, is to write a textbook. You kind of accidentally,
absolutely not. No, absolutely not.
And I mean, you probably expected that, 15 years later, you'd be on the trial in Dover, right? That's exactly why you got into this, right?
I didn't expect to write a book, and I certainly didn't expect to go to court. But I will.
That's not very often. I mean, like, Nathan, how many times have you been on the stand in a trial?
Well, remember, I do forensic work, so I actually do end up in legal proceedings sometimes. Not often. I testified last week.
I've never actually been in a trial. I hope I never have to be.
That is a goal that you should aspire to. I've been on the stand twice. The Kitzmiller trial, which you want to talk about today, and that was preceded by almost a year by a trial called Selman versus Cobb County. And the Selman trial concerned a school district in Georgia that decided that evolution was so controversial that they would put warning labels on textbooks to tell students it was just a theory.
So it's interesting because it is a very strange thing to end up, because you write a book and then over a decade later you end up in court, I guess, twice over it.
Yeah.
It's funny. I mean, that's not, I think, how anyone really expects things to play out. We had Michael Behe. I mean, I was in it was basically me on another podcast, ended up being in People Science too, where we talked about it. He explained it as Kafka-esque, and it's a pretty colorful way of putting it. I kind of want your take on it, but I think the best way to understand it, he was saying that this is just a very foreign thing of being a scientist here and not really knowing what's going on and why. I'm just kind of curious how it was for you. What was your personal experience? And then, you can also comment on what he thought about it too, but I'm really curious.
Well, you're talking about the personal experience in the courtroom, right?
Yeah.
Yeah. Okay. Well, certainly I did not expect, I had never expected.
It is kind of surreal, right? To kind of end up in this bizarre spot.
To end up in a courtroom. But let me sort of explain things a little bit.
Okay.
My very first semester when I was teaching at Brown, which was 1980-81 in the springtime, I had taught part of the introductory biology class in the fall, and apparently I'd made a good impression. Because in the springtime, while I'm setting up my lab, a group of students came to see me, and they said, "Boy, you're a really terrific lecturer. You're really good up on the stage in front of 300 or 400 students." And of course, I said, "Oh, shucks, thanks a lot." But they said, "How did you come to become so at home in public speaking?" And I said, "Well, when I was in high school, I was the kind of kid who was involved, I guess you would say, in school politics. So I was elected student government president. I don't know if you or any of your viewers have heard of an organization called Boys State, which is a program that American Legion runs around the country. They pick kids from high school. They set up model state governments. They have elections. Well, I was elected the governor of New Jersey Boys State in 1965, and I went around the
from Rhode Island, right?
Pardon me?
That's a step up from Rhode Island, right?
Oh, no, I don't want to insult Rhode Island, okay? But it certainly is a larger state, okay?
That's what I meant.
We'll put it that way. And also, and this was my mistake, I said also I engaged in debate in high school.
Boys State place, did they let girls in too?
There's a boys state and a girls state. I don't know. I don't think so, man. I don't know if they've been combined right now. But when I was in 65, a boys' state was held at Rutgers University, the state university, and girls' state was held at Douglas College, which was the female version of Rutgers, because they're right next to each other, separate. And actually, for a while, and I'm revealing something intimate right now, for a while I dated the governor of girls' state. We really had something going on for a while. But anyway, when I told the students I had engaged in debate in high school, they said, "Great, we're from Campus Crusade for Christ, and we have invited the country's foremost so-called scientific creationist, Dr. Henry Morris, to come to Brown and give a lecture, and he has challenged anybody in the biology department, the geology department, anybody to debate him."
When was this?
Pardon me?
When was this?
April 1981. To debate him on the theory of evolution. And you're a good public speaker and you've done debate, so why don't you do it? And my answer was, go away. I'm setting up my lab and I'm a cell biologist. I'm not an evolutionary biologist. And they said, "Well, does that mean he's right?" And I said, "Of course he's not right. I mean, evolution is.
We should also add, you're also a Catholic, right?
Yeah. Well, that didn't come into view until later. But I said if there was really a fundamental flaw, a great error in evolution, scientists themselves would be picking it apart. We don't have to have somebody whose background is in the ministry come in and do this. Well, eventually they talked me into it. And you and your viewers may not believe this, but the students had some expenses to defray. So they sold tickets to the community at about $1 a piece. Students could get in for free with the university ID. When they sold 500 tickets, they figured we got to move this to a large lecture hall. When they sold over 1,000 tickets, they panicked. And this debate had to be moved to the largest room on our campus, which, knowing New England, naturally enough, is the ice hockey rink. So in April of '81, the ice was gone.
And just for reference for people following, I'm sure you know this, Henry Morris was really the author of the Genesis flood. It was a big deal. He's really the father of young earth creationism.
He is yeah, that's right. He is the father.
And this is like before Ken Ham.
Yep.
For
founder.
All these guys. It was really Henry Morris. They all really owe it to him.
Yeah, he's the guy, the founder of the Institute for Creation Research.
It's actually not even about evolution. It's flood geology is the real core piece.
Yeah, and we can get into that. But in any event, when I realized what was going on, I practically panicked and decided I have to drop everything in terms of lab setup. And I spent 5 weeks before the debate reading all of Morris's books, listening to audio tapes of his previous debates, and quite frankly, looking up every one of his individual, very peculiar arguments, arguing that the Earth was young and that geology was mistaken and evolution was impossible and so forth. And by the time the debate came, I actually had, and this is before PowerPoint. This is the old days of regular old 35 millimeter slides. I went to that debate with 2 carousels of over 150 slides ready to rebut every single one of his arguments, which I did. Now, 2 things occurred to me after that debate.
Is this videotaped anywhere or something?
Oh, there are no videotapes, but there are audio tapes, illustrated audio tapes that are available at the National Center for Science Education.
Oh, we're going to find those.
I can send you a link to that if you like.
Have you seen this stuff, Nathan?
But here's the interesting thing. Remember, I was not an evolutionary biologist, but I educated myself as quickly as I possibly could. So there were 2 things that really motivated me to sort of get into this issue. Here's the first one. I could have won the Nobel Prize, and I could still not have drawn 2,000 people to an event like this. And it told me that people feel passionately about this. And at the time, the year is significant. There were 2 states, Louisiana and Arkansas, who had passed laws requiring the teaching of so-called creation science in the school. So this was a hot issue. Neither law had been tested in the courts yet. So therefore, a lot of people thought, hey, maybe there's something to this. Then the second thing was immediately as the debate began, Henry Morris brought up the issue of my supposed atheism or agnosticism, because, of course, all evolutionists are atheists. And I just looked at him like, I'm not making any special claims for myself, but I'm a practicing Roman Catholic to the best of my very poor ability. And I know very well that there are people who are evolutionary biologists and are people of faith. And I also know that at religious universities, take Notre Dame, take the College of the Holy Cross, evolution is taught and accepted as scientific facts. So no, you're not going to push me into a corner by saying that evolution has religious content that requires a sort of obligatory atheism. And that motivated me to write a couple articles about it.
Now, to frame that, wouldn't you agree that some tellings of evolution can have that like atheistic spin to it, but that's not necessarily the science maybe, but there's some people who kind of try and present it that way?
Here's what I would agree with, Joshua. I would agree with you that evolution is an extremely powerful and successful scientific theory. And as such, people try to enlist it in various causes. So it's been enlisted, for example, in attempts to do social engineering, like eugenics. It's been enlisted, for example, in the favor of collective socialism, and you'll see that in some of the socialist countries and republics in the 20th century. And it also has been enlisted in the cause of atheism. In other words, to say there's really only one argument for the existence of God, and that is the special creation of all creatures.
And I want to be clear too. We're not dumping on atheists here, because like Nathan, you're an atheist. You're not hearing it in a negative way.
No, of course not. I'm not talking. What should I say? Some of my best friends are atheists. That's absolutely true. My point here is that evolution is empirical science about the origin and diversification of species. It's not either a theological or an anti-theological system.
I mean, well, I agree. I think that I think it certainly challenges certain theologies too. So I think that's where some challenge comes. And
yeah,
I think what's interesting too, because you're chairman of the board at the National Center of Science Education,
correct?
Which is an organization that is really often painted as atheistic, but you're a Catholic, and Eugenie Scott's an atheist.
Right.
Glenn Branch is an atheist who's there now.
Right.
But is it an atheistic organization? Why would a Christian work with them?
Okay, well, I do remember I've been associated with the organization for a very long time. And I have been slandered by people saying, well, Miller makes common cause with the atheist Eugenie Scott, or this, so forth and so on. And
she wants to be called a secular humanist, so he makes common cause with a secular humanist.
Yeah, no, exactly right. But here's the way in which I would put it. And that is properly understood. Science itself is not atheistic, rather it is non-theistic. And the reason for that is the existence or non-existence of God is not a testable scientific question. You can't put God into an experiment.
It's more like silent about God more than being anti or pro God, is what you're saying.
Yeah, so that is certainly the point. Now, I don't consider being called an atheist a slur. What I do consider basically is being told that acceptance of science implies a particular anti-theistic point of view is an overstatement of science and the misstatement of reality in terms of what people of faith believe in general and in particular.
That makes sense. What's your thoughts, Nathan?
Sorry, unmute. I agree with everything you just said. I don't have a religious belief myself. I once did, but the realities of science that I've been studying for my whole career had nothing to do with that transition. So also because I was raised Catholic, I never saw a tension between evolution and faith anyway. I mean, I grew up in religious classrooms with crucifixes on the wall talking about evolution. There was never, I didn't know there were people that didn't believe in evolution until I got to college. And when I got to college and I was in my evolutionary biology class and the instructor's like, I know some of you won't, agree with some of this. And I looked around, I was like, who wouldn't agree with this? And sure enough, there were some fundamentalists in the room who had a problem with it. And to me, that was something I saw on TV at the Scopes trial, and it never really dawned on me that this was a contentious issue.
Yeah, Nathan, I have to tell you, I had the same experience growing up. I went to public school, not Catholic school, even though I come from a Catholic background. And I never knew there were people who denied evolution either. And you're going to love this story until the 1964 New York World's Fair. And the reason for that is I was a Boy Scout. And I was picked, along with a lot of other scouts, to be part of what was called the World's Fair Service Corps. So we had special uniforms, and for 4 hours a day, we had to work, you might say, as tour guides in the Boy Scout Pavilion at the World's Fair. And I was there for a 2-week stint. Now, the cool thing about being in the World's Fair Service Corps was that once your 4-hour stint was up, you could then go anywhere else in the fair. And the people at other exhibits, they recognized that special uniform and they let you in the front of the line. So I got to see like everything, ride every ride, do everything at the World's Fair. And I was already interested in science. So I'm walking around with a couple of buddies, and there's an exhibit for something called the Moody Institute of Science. And I thought, well, that sounds pretty cool. Let's go in and watch the presentation. Well, this is an affiliate of the Moody Bible Institute, which I didn't know about at the time. And we watched a very slick video or film presentation, and it was all about how evolution is a lie and evolution is wrong. And that was honestly the first time in my life that I was ever confronted with that point of view. So it was
you guys look out of touch because you didn't know my family existed. Like I grew up.
No, apparently not.
Yeah, I mean, this is the part where what I found actually is that I think I gotta say there's a lot of stereotypes about young Earth creationists. There's a sense that they're not educated. I know a lot of really educated young Earth creationists that they don't care about science. A lot of them really do. They're often very smart people. I was a smart, educated one too. It's just that I'd never really been exposed. I would, in a really big way, I wasn't really exposed to science at a high level with trustworthy people, and it was only really later in life, honestly, with that combination of really high quality science with trustworthy people that weren't actually out trying to enlist science to do something,
sure,
but just try and explain it to me that I had a chance to even see it differently. And so yeah, but there are a lot of us out there, that it's weird. It's almost like it's a different world. I mean, because you guys are up, I guess, in the East Coast. I was in Southern California, right? And it was about that far apart in the world, right?
Yeah, I think that's true. I mean, I have to tell you that almost every year in my freshman biology class, and I start off that class with ecology followed by evolution. Almost every year I get a couple students who come into office hours, and they're very polite because, of course, they're freshmen.
Probably scared too.
and they start asking in a roundabout way something, and all of a sudden I realize what they're getting at, and I say, aha, what you want to know is if you have to believe in evolution to get an A in my class. And very often when I say that, you can see, oh, the dike is breaking, they blush or something like that. And the last time I put that to a student, I said, well, what did I talk about in class today? And he says, well, you talked about the Krebs cycle. And I said, well, fine. I want to tell you something. I don't believe in the Krebs cycle. And he said, what? And I said, no, I don't believe in the Krebs cycle. I don't believe in photosynthesis. And I certainly don't believe in RNA and DNA. And the student was flabbergasted. And I said, the reason I say that is because in science, we don't believe in things. With respect to the Krebs cycle, I understand the position that the Krebs cycle holds in intermediary metabolism. I understand the evidence for the Krebs cycle and for each of the chemical reactions within it. And I also understand why the scientific community, why biochemists find the Krebs cycle as an explanation for metabolism persuasive. Therefore, I accept the scientific evidence. But that's really different from the word believe. And therefore, I'm not asking that you believe in evolution. I'm not going to throw you up against the wall and say, do you believe? What I care about as an instructor is that you understand the evidence for evolution, you understand the mechanisms by which evolution works, and that you understand why the scientific community finds it persuasive.
And you don't even have to agree at the end with it.
Yeah. My goal as an educator is to promote understanding. It's not to compel belief. And in general, that gets them relaxed, and as it should.
Well, I think that's actually one of the big, cultural clashes, because in the young Earth creationist community that I grew up in, at least, I mean, it's like a statement of belief. It's not merely do you understand, it's do you personally assent to it.
Sure.
And science actually doesn't work that way. We don't have belief statements. We don't actually really care if a person agrees. We care about the quality of their public work and if what they're saying and they understand, right? So that's a very different thing, right?
And you can be moved by really one good piece of evidence. I remember my PhD was on an enzyme that at the first half of my PhD, we were writing about how critical it was for all of this stuff. And then the knockout mouse came out and it had almost no phenotype. So we had to immediately change exactly how we were thinking about this enzyme. I said one really good piece of evidence should be enough. And that's what we've always said about, major evolutionary transitions. I mean, if you really wanted to disprove some of this stuff, one really good fossil ought to do it, but we haven't found those.
Yeah, Ernst Mayr, the late Ernst Mayr, the great Harvard evolutionary biologist, was often asked what evidence could disprove evolution, and he would smile and he would say something like, "Find a fossil of a rabbit in Precambrian rock. That would do it."
Well, I mean, I think let's be serious though. I mean, there's a lot of reasons why fossils can be out of place. Like maybe someone dug down and put it inside there. So
Sure.
I mean, it's a little more complex than a single.
No, but assuming that all that checks out, I think is what he means.
Yeah, and let me make an argument that's much more specific, okay, than the facetious rabbit in Precambrian rock. If one wants to argue, as Ken Ham and other young Earth creationists do, that there was a simultaneous creation, and there were contemporary organisms living, what we consider contemporary, living side by side with dinosaurs and other supposedly prehistoric organisms. Do you know how you could disprove that? And the answer is you could disprove that by the careful analysis of coprolites. Coprolites are fossilized feces. And we have plenty of examples of very rich coprolite beds that date from the Jurassic and other areas when dinosaurs were common. So in other words, we've got dinosaur poop. So that all you would really have to do to disprove evolution was to take apart dinosaur poop and find in it evidence of crushed bones and other things from contemporary living organisms. Now, the curious thing is that if young Earth creationists really believed in the scientific creationist, in the simultaneous creation of organisms, the investigation of coprolites should be a major research field that would support young Earth creationism. But I've never found one who displayed the slightest interest in it. And to me, that suggests that they're really not about to be persuaded by
harder to directly handle it and look at it. And you never know if there's cherry picking and things like that as a person who's outside the field. Not to say that it isn't solid work. It's just that it's harder to have direct visibility on it. What really made a big difference for me is actually seeing the genetic data, where, you know, now a high school student can download the human genome. They can download the chimpanzee genome. And there's actually, you know, I'm a computational biologist. I don't actually, for me, you know, biology isn't like cooking. It's, you know, like programming. And so, you know, I'm mathematically oriented, and, you know, there's these really simple mathematical, equations that explain like the patterns we see. And there's nothing like that explains those patterns in young Earth creationism. And so, or even old Earth creationism. And so what I know is that there's just an immense amount of, you know, data out there that is, very precisely explained by, you know, math in a way that, you know, we need to have some other explanation that doesn't include common descent to move away from evolution. And no one's really been able to produce that. And I think that I think is the bigger, I mean, that's like the big knockdown thing for me.
If we did not have a single fossil, the evidence for evolution would still be overwhelming. And that is especially true on the basis of the genetic and molecular evidence that you just cited. That is absolutely astonishing. And, you know, I'm going to invoke the name of a religious person here, okay? Which is in 1996, Pope John Paul II wrote a letter to the Pontifical Academy of Sciences in which he talked about the evidence for evolution and basically why the church had no problem with it. Now, that's a theological issue. But in that letter, and I wish I could quote this exactly, he said, the convergence of so many different lines of evidence, neither sought nor expected, upon this single explanation, and the explanation was evolution, is itself a significant argument in favor of the theory. And what John Paul II, who was a very well-educated man, was talking about was that the convergence of sciences that didn't even exist in Darwin's time, genetics, molecular biology, biochemistry, some of the sciences of plate tectonics and so forth, all of these different sciences have converged on a single point of explanation for the diversity of living things, and that single point is evolution. So the fact that unrelated sciences could come to the same conclusion is about as powerful an argument as you can make in favor of the validity of evolution.
I think it's worth pausing for a moment, explaining what we mean by evolution. I think what we're talking about right here is really this idea of common descent with modification producing the diversity of life we see on Earth. I'll tell you what I think. You can tell me what you think. I don't think that this rules out God's involvement or his guidance or his role in it. I mean, it doesn't provide any strong evidence for God's involvement, but it's not like it rules that out. I mean, you know, there's a lot that we don't know about the past and the history, and, you know, we just don't know. But the fact that we don't know everything doesn't mean we don't know some things.
No, that's absolutely true. And in terms of we don't know everything, if we did know everything, It would
It
be
wouldn't be science anymore.
to close every department of science at every university in the world, and we could just read books. Okay, so obviously we don't know everything, but the notion that evolution does not rule out God, it's been around there for a long time. I mean, way back.
Let's pause.
Way back in the
We're going off the Dover trial too, because you're right. So why is it that in the Dover trial and all these things, it was set up as like, theism versus atheism? I mean, I thought it was interesting. It wasn't even Christianity versus atheism.
Sure.
Theism versus atheism.
Right.
Like, why is that philosophy put there?
Well, let me give you an example. I was scheduled to I scheduled a testimony on the very first day of the trial. So I was the lead witness for the 11 parents who were plaintiffs in the suit. And I figured I would give my testimony in the morning. And then in the afternoon, this is a Monday afternoon, I'd be cross-examined. It would be done.
What date was that?
And then I would fly home to Providence. The trial was in Harrisburg, Pennsylvania.
But what date was that that Monday? Do you remember?
That was September 26th, 2005.
Cool. And that's where the infamous, well, not infamous, that's where this comes from.
Yes, that is the afternoon of the first day of the trial. I'm on the stand. Judge Jones, a Republican appointee, is looking down. To my right is Richard Muse, who was one of the attorneys representing the Board of Education. And it's sort of blurred out in the picture, but right next to the letter P in Peaceful Science is a stack of my textbooks on the table.
So in your book, Finding Darwin's God.
And Finding Darwin's God is right next to it. And they did have those books there. So I figured I'd wrap up in the afternoon and fly home. Well, my cross-examination didn't end that day. It went on for almost 9 hours. So therefore, I had to stay overnight, and I was on the stand the very next day. So we wrapped up about midday on Tuesday. I caught a flight from Harrisburg, went home, picked up my car at the airport in Providence. And as I was driving home, I turned on National Public Radio. And sure enough, they had a news report on the trial. And the voiceover leading into it was an announcer who said, "It's God versus science in a Pennsylvania courtroom," with a very nice dramatic flair. Now, the interesting thing about the whole God versus science thing is we had 5 expert witnesses on our side of the case. 2 of the 5, myself and John Haught, are people of faith. The others were not, no matter. And John is actually a professor of theology at Georgetown University, again, testifying on the evolution side. Then there were 11 plaintiffs. Of the 11 plaintiffs, at least 5 of them were also people of faith, and 2 of them were Sunday school teachers. So the notion that somehow Kitzmiller was a science versus God case was absolute nonsense. And I should also point out that Judge Jones is also a faithful churchgoer as well. So the idea that this was a God versus science confrontation is manifestly false. What is true is that it was a confrontation that was aimed at determining whether or not a fundamentally religious idea can cloak itself in a garb of science and basically be inserted into the science classroom, thereby allowing not just religion, but a particular religious point of view to be taught as though
the way they would object, and I want to know how you'd respond, and I do think there is some potential legitimacy to this too, is that you're a person of faith, but you're talking about evolution and you don't mean it in a religious way. So you can be a person who has religious ideas, but then you talk about components of it in a non-religious way. And in the same way, take a person like Behe. I think he genuinely believes, and we can talk about whether it's a good scientific point, but he believes he's making like a non-theological, non-religious, clear scientific point. And I think that that's probably true. Now, I think he's wrong on the facts and on the logic of it all. And I do think that some people impute his argument with theological meaning, but I don't think he means it in that way. Isn't he making a secular argument? Isn't that fair for him to say? Isn't that truthful?
You are talking about the views of one particular person, Michael.
Yeah, let's talk about him.
And I completely agree with you that Michael Behe is profoundly sincere, and I have absolutely no argument with that. And in fact, I've debated Michael.
So you agree with the reducible complexity? I think you actually do have an argument, but not with his honesty.
Okay. No, not with his honesty at all. Okay. I've debated Michael in print, in person, in TV interviews at least 10 times, leading up, in fact, to the Kitzmiller trial. And I have absolutely no doubt of his sincerity. But here is the point. I attacked, when I testified, I had a couple things to do. One is I had to explain the scientific support for the theory of evolution. I had to explain how textbooks are put together. How do you make a judgment as to what goes into a science textbook? And I did that as well. And then you got to remember, a trial is not a debate. My testimony came about 3 weeks before Behe's testimony. So in order to anticipate it, what I had to do is I had to tell the judge what Dr. Behe was probably going to say on the stand. And then I had to tell the judge why that was wrong, what was wrong with it. And if I had misrepresented what Dr. Behe was going to say, that would have completely undercut my arguments as to why this is not accepted in science. And not for a second was any part of my testimony or any part of the cross-examination by our attorneys of Dr. Behe, not for a second was any of it focused on his religious beliefs, religious intent, and so forth. What I focused on is simply the scientific errors in this
so what do you mean when you say it's like a religious idea? Isn't that like not really fair to him? I mean, don't you want to say like people making use of a scientific idea for like inscripting it?
Well, yeah, but that wasn't. Yes, that is actually the key argument in the Kitzmiller trial, but it's not something I would make against Dr. Behe himself, because I think he's honest and profoundly sincere. But here's the thing that was established during the trial. The first thing is that the concept of irreducible complexity has failed to gain any traction at all within the scientific community beyond a handful of people, most of whom actually turn out to be religiously motivated. But here's the second thing. The intelligent design movement was set up in a very calculating way to basically take scientific creationism, get the word creation out of it, and cloak it entirely in secular language. Now, I'm not the expert who showed that. The expert who showed that—
Barbara Forrest, right?
Right, was Barbara Forrest. And Barbara was the key to the trial, because what Barbara knew where all the bodies were buried. She knew the meetings, the strategy meetings that were held by the intelligent design movement.
And like the Wedge document. But Nathan, you just read her book, right? What do you think would be like an example of like a key thing that you learned from that? And what's the name of her book again? What is it again?
Well, I mean, the Wedge of, oh shoot, I forget. The Wedge of Intelligent Design. It's called Creationism's Trojan Horse, the Wedge of Intelligent Design. And one thing I just want to say, everything that Dr. Miller just said is right on. The founding of the Discovery Institute was, I mean, this is right-wing political Christianity. And the idea that they come to this through just a unbiased look at the evidence is just simply not true with the historical record. Now, Michael Behe himself may truly read the scientific evidence and get there. However, he was there at the founding of the DI. He has defended the Wedge document, and he did again in Darwin Devolves. So I mean, it's a very charitable interpretation of him, and I think he seems to be a nice guy, so that's fine. But I have the idea that this is a religious idea first. I think the evidence for that's overwhelming.
You take something like
it's a religious idea first, and then they're wrapping hold on, and they're wrapping their interpretation of the scientific evidence around that. Now, if Michael Behe's doing it unconsciously, that he's just finding the evidence lacking, and then okay, but I mean, like I said, he's surrounded himself by the same kind of people, and at the same time, and when the Wedge document, when he was questioned about it, he's like, "What's the big deal? It's a bunch of people who are decided that this is what they want to see happen, and they're working towards it. I don't see what the controversy is. The controversy is that they pretend that it's science, and it's not."
Well, I think there's an interesting contrast. I want to hear both of your take on this. To looking at the Big Bang and the idea of a beginning to the universe, which was about 100 years ago. That really did start in religious circles, like this idea. I mean, like the guy who brought it forward was a priest, or he used to be, right? Lamartine.
Belgian Jesuit.
I mean, he was very clear that he's putting forward a clearly only scientific, non-theological idea. And it was to the resistance of a lot of physicists at the time. But, you know, the evidence really ended up bearing him out.
Well,
and he won, right?
It's a great example.
If you would, Joshua, let me speak to that. Georges Lemaitre was a Belgian professor.
Was it Lemaitre? It's not Lemaitre. I mean, am I mispronouncing it?
I don't speak French.
Okay.
The only other
I'm
language
going to stumble through how to. I got to go talk to a friend.
the only other language I speak is German, and that's no help here. It looks like Lemaitre, and I have been told it is Lemaitre. But nonetheless, Georges Lemaitre was a professor of mathematics and physics at the University of Louvain in Belgium. Well, he was also a priest. And he was one of the few people in the world, clearly, who profoundly understood general relativity when Einstein published his equations for that for the very first time. And he began to go to scientific meetings and argue that general relativity implied an expanding universe. Now, Einstein, for what I might term anti-theological reasons of his own, preferred to believe in a steady state universe. You can find this out in Walter Isaacson's book.
He called it the biggest blunder of his life, what he did with the cosmological constant.
Well, he thought the universe always had been and always would be. Therefore, you do away with any need for a creation event. So here is this young physicist, a very bright guy, wearing a Roman collar, coming up to him at meetings and saying, wait a minute, the universe has to be expanding. That means it'll be bigger tomorrow, but it also means it was smaller yesterday and still smaller a month ago, and years ago even smaller. And if we go far enough back into the dim and distant past, it means the universe was, and this is Lemaitre's terminology, the universe was a single atom. And that's cosmic expansion. And that's what we commonly call the Big Bang. Now, Einstein resisted this for a very long time. But of course, Hubble found the background radiation. Hubble discovered the redshift, which indicated that galaxies were moving apart at velocities that were conversant with that. And then Robert Wilson and Arno Penzias discovered in the 50s the microwave radiation background of the Big Bang. And Lemaitre lived just long enough to see his ideas vindicated by Wilson and Penzias. And you said he used to be a priest. No, he was a priest his entire life.
Well, so this is an important point, though, because he really did face that objection that this is just a religious idea. And in fact, it was consonant with the religion. Maybe religion even had like a background view to it. Who knows?
Yeah, but
this is just a scientific idea.
Yeah, when Lemaitre's ideas became generally known, Pope Pius XII got very excited. And he actually issued statements that said Father Lemaitre has discovered the moment of creation. And Lemaitre had to correct the Pope, and he did so.
Yeah.
This is, he said, Holy Father, I have not discovered the moment of creation as in the book of Genesis. This is a scientific theory. And what I have discovered is the universe expands from a single point. By saying that I have discovered sort of the theological equivalent of creation, you're overstating what science can say. So Lemaitre was not hesitant to correct the Pope on a matter of science, for which I
think the parallel is important, because I think if you take him and Behe, I think both of them actually faced like opposition from the scientific community, at least initially, right? I think both were claiming to be privately religious, but be putting forward scientific things. And somehow Lemaitre, for reasons that I think we can explain, was able to overcome that prejudice and really become the dominant idea now. And but the idea
because the evidence was on his side,
hasn't, right? And I think the reason why is the science isn't there.
Yeah, the evidence is on his side. That's all it takes.
Exactly.
That's all it takes.
And it's not just a question of Lemaitre overcoming and Behe trying to overcome, as this is some sort of personal struggle.
I agree. Really,
the thing about science is that it's empirical. And there's a famous quote that's saying there's nothing quite as tragic as the murder of a beautiful theory by a gang of ugly facts. But in the case of intelligent design, I would say, look, the facts are against it. And I actually took, in that testimony and in some writing I've done, virtually every one of the arguments that Behe advanced for irreducible complexity, and showed, in fact, that every one of those arguments fails on a scientific basis. Not on a theological basis, but on a scientific basis, and that's the point.
So this is also a little personal to me, too, in another way, because, I think this comparison between Lemaitre, I'm going to say Lemaitre, and someone...
Yeah, that's cool, don't worry about it.
But, there's a similar thing. I mean, you very kindly agreed to read my book, and you're going to be responding to it at AAR in a couple of weeks. I'm really looking forward to hearing that. Nathan, you read my book, you endorsed it. I have to, I mean, you guys have to agree that, at least on an initial blush, like the thesis it doesn't sound right. It sounds like it's religiously motivated, and it's not going to be good science. It reminds a lot of people of young earth creationism like Morris, but yet somehow that idea has really convinced a lot of scientists, well, his scientific points are solid. And I mean, I've certainly seen that prejudice against it. And I've also seen how scientists, even atheist scientists that don't like religious views at all, who might even be called anti-religious, not like you guys, how they can be kind of deal with the evidence and actually come and actually change their mind on that, which I think speaks to something about science. I mean, would you comment on that?
Nathan, go ahead, because I haven't finished the book yet.
Well, I mean, I think the key thing for me for deciding to endorse it was not that it makes a positive claim with all this evidence behind it, but rather it found a way to create space for a religious idea that would be consistent with the evidence as we have it. And, and I think in the longer version of my endorsement, I even say, it's possible that we're going to learn some things 10 years from now that'll make this untenable for various reasons. And it's not even that hard to imagine what that could be. But that would also mean that some of our current scientific understanding isn't quite right. That's normal too. That's part of the process, right? If you look, you can probably find, Dr. Miller, you can speak to this, probably your first version of the textbook, some of the stuff you had to revise, you're like, it wasn't quite, what we thought. That's how science works. And people are like, oh, it's wrong, now it's right. It's like, no, you're zooming in on or homing in on the truth, which means that you're not quite there all the time. You never really quite get there to the full and complete picture.
Well, and I think a big part of what I'm doing too is emphasizing the limits of the evidence, which is something that scientists really care about. We want to know what the evidence shows us, and we want to be truthful about what it doesn't tell us, right?
Yeah, Nathan mentioned my textbook. When our book first came out, I visit high school classrooms all the time because a lot of high school biology teachers know my name, and they invite me to go places, and I never turned down an invitation. I do it all over the area where I live and so forth, and it's a lot of fun. And when our first book came out, a student, and I believe it was a student in Texas, because it was in Texas at the time, asked me, are you sure that everything in this book is true and correct? And my answer was, let me tell you what I'm pretty sure of. I'm pretty sure that 20% of the stuff in this book is wrong. But the problem is, I don't know which 20% it is. And what's going to happen, and that I think reflects the state of scientific understanding. And of course, what has happened is, the reason why this book had a lifetime of about 6 years, and it was succeeded by this book, which is the one that was actually used in Dover, Pennsylvania, and it was succeeded by another book, and I could bring up yet another one, is because after 5 or 6 years, there is so much ferment and change in biology that it is literally time to tear up the table of contents and start over again. And that reflects simply the process of science. And one of the things I actually find quite exciting about being a co-author of a textbook that presents biology to ninth grade kids, 14 and 15-year-old kids, is that I get an opportunity to constantly say, well, we thought we understood this, but now there's new evidence and we have a completely different understanding.
Have you ever had a high school student contact you with an error that turns out to be correct? I mean,
yes, repeatedly. And I have extra copies of my book so I can autograph it, gift wrap it, and mail it back to them with my thanks. This happens all the time. And
is there like an erratum somewhere online where people can see, or?
No. I sort of do that one-on-one. And I like to think that I'm really encouraging a young person to go further in science when I do that. But I think that's important to emphasize that science is not static. There are plenty of mistakes in there. Our latest textbook is actually the first high school textbook to have in it a detailed treatment of the CRISPR mechanism for gene editing. And I have to tell you, there's new data that has come out in the last month or so about unintended off-target effects by the CRISPR technique, which I did not anticipate when I wrote the update in our latest textbook. And in the next revision, I'm probably going to have to get into that one way or another. But that's what makes science interesting. It's not like teaching ancient Greek where nothing changes. Things change all the time.
Well, I mean, let's talk to the people who study that. They'll probably talk about things that are changing. But
I'm sure you're right. I'm sure you're right.
But you're right. I think that it's just so massive. It's not tamed. Biology isn't really tamed, and it's not tameable. I mean, we don't really know what the next thing is that we're going to find.
For sure.
Yeah, the example I use when I talk to my students is that when I was in college and even the early part of grad school, microRNAs weren't known. They weren't even really known. And we study them now in my lab. And I was like, this wasn't known when I went to college. A whole class of molecules with profound implications throughout our body. Every cell in our body is remarkably different because these molecules exist. And we didn't even know about it when I was in college. Didn't know about it at all.
Well, I think that's honestly the crazy attractive thing about science at large, but also biology, just how much of it's important, but we don't know, or we think we know, but we really don't. And, it's just this grand invitation to mystery, to really dive in and learn and figure new stuff out, right?
Yeah, I mean, there's a quote that I never tire of repeating from Einstein, which is, the most beautiful thing we can experience is the mysterious. It is the source of all true art and science. And because I'm married to an artist, I love the marriage of art and science in that quotation, which is that just as the best art is mysterious, like, what does that really mean? I think the mystery that is inherent in science is one of the things that draws us to it, because for all we know about living things, many things are still shrouded in mystery, and the idea of getting a peek into that was exciting to me when I was 14 years old and looking through that microscope, and it's exciting to me still.
Well, it's a great way to end. We're coming up on an hour, and hey, I just want to thank you for being part of the conversation with us. Some people are going to agree with you. Some people will not, and that's okay. I think we just really want to give everyone a chance to kind of talk about this really, profound event. It's been really exciting to have Bihi talk about that. And now Nathan wants to say something. I'd love to hear what you have to say.
Ken, if you would, can you just tell us why the mousetrap analogy is just such a poor way to think about complexity?
Well, I'm looking around my office to see if I have a mousetrap handy. And the reason for that is often I do, but I don't have it here right now. But Michael Behe pointed out the inherent complexity of biological and biochemical systems, which are made of interlocking parts. And one of his examples was a common mousetrap. And a mousetrap has 5 parts. It has a base plate. It has a little bait holder. It has a spring to activate the base holder. I'm probably leaving it apart. Oh, that's right. Then it has the hammer itself that does the business of the mousetrap. And then it has a little catch that keeps the hammer back until the mouse nibbles at the bait and then snap. And his argument is that that's an analogy for biological systems. Every one of those parts is essential to the functioning of the mousetrap. No argument about that. And if you take away any one of the parts, what you have is a useless contraption. It's good for nothing. Well, one of the things that struck me about that is Michael's right, that in order to catch mice, you need all 5 of those parts. But does that mean that a subset of those parts is absolutely useless? And the answer turns out to be no. So one of the things that I did at the Kitzmiller trial is I took, not on the stand, I did it before the trial, I took a mousetrap and I pulled off the bait holder and I pulled off the catch. And what you then have is the base plate, the spring, and the hammer. And I peeled back the hammer and I used the mousetrap as a tie clip. And it turns out it is a perfectly functional, if somewhat inelegant, tie clip. And here's the point, and that is a subset of the parts in a supposedly irreducibly complex system can still perform a useful function. Why is that relevant to the issue of evolution? Behe had argued that when we look at complicated biochemical systems, like the blood clotting system, for example, which there are 13 or 14 biochemical parts, he was arguing that if you take even one part away, the system stops functioning. Since evolution cannot produce like 12 parts thinking at some point I will evolve the 13th or 14th because there'd be no selective advantage. That, he believes, is an argument against evolution. But it turns out the other parts of the blood clotting cascade are still functional in different contexts, and therefore their evolution can and is favored by natural selection. So by taking his favorite analogy to an irreducibly complex system and showing that a subset of parts is still useful for something, I basically explain why the irreducible complexity argument fails.
So you'll find this entertaining. Last week when I was when we did podcasts, he brought up the mousetrap analogy, and I gave far less.
He's still using it.
Elegant way of explaining it, but the way I explained it was the more technical term acceptation. But then later in the interview, and I want to know if you can resolve this for us. I thought this was fairly remarkable. I was actually fairly stunned. I said acceptation. He said he knew about that and all, but later on he says, the problem is that the only way how evolution progresses is by breaking things or rearranging existing parts. And I'm like, but wait a minute, isn't rearranging existing parts acceptation?
Exactly.
And he said, no, that's not acceptation. And I was like, what? Isn't rearranging existing parts acceptation? I thought that's what it meant. Did I misunderstand?
No. You understand it all too well. Acceptation.
So he functions can arise then by rearranging parts.
Acceptation is a word that was coined by Stephen Jay Gould.
Okay.
To replace another term that wasn't quite right. And the other term that wasn't quite right was pre-adaptation. And the notion of pre-adaptation is there can be systems, molecule structures that are well adapted for one purpose. But in retrospect, we can see that they are actually useful in a different context at some point in the future. So you might say, for example, that the feathers, which appeared on dinosaurs, probably for thermal insulation, turned out to be ultimately useful in flight, even though that wasn't what they evolved for. So the evolution of feathers is an example of pre-adaptation. Pre-adaptation kind of implies foresight, which is why Gould didn't like it. Acceptation means basically you're taking something that is perfectly functional in one context and being able to use it in a different context, which in this case was flight. So that's where acceptation comes from, as in terms of word origins. But pre-adaptation is, I think, a fairly good description of what happens here. So I'm sorry, B was mistaken about that.
And I was right. That's great. Anyways, what a wonderful end, right? No, I'm sure I said other things that were wrong. Thank you so much for joining us, Ken. I'm really looking forward to seeing you at AAR, and I really appreciated honestly how NCSE really was trying to kind of map out a neutral way forward during all those years, and I saw that even before I got a chance to meet you guys, and even before I was on board with evolution in a lot of ways. So
yeah, and I would point out that NCSE has done that for a very long time. My predecessor, as chairman of the board, president of the board of NCSE, was Francisco Ayala, who was a very famous geneticist. Still
around. UCI, where I went to school.
That's correct. And Francisco is actually a former Catholic priest, and he had written a number of books and essays emphasizing the compatibility of science and faith. The idea that science is not.
Yeah, honestly, though, it gets a little complicated for Christians because, that's another story. Maybe we'll have him on sometime if he'll come.
Yeah, we could do theology sometime in the future. Right now, we've just been talking about science.
Any last words, Nathan, before we close it up?
Just thanks again, Ken. It was great to see you again. It's been a couple of years, but nice to see you.
Yeah, absolutely, Nathan. Always a pleasure. Hope to see you later.
All right.